Hello again, welcome to the second video in covalent bonding. This one we're going to look at covalent molecular substances. So we just in the last video we introduced you to them, and we're going to look at them in a bit more detail now. So covalent molecular substances, most non-metal elements and compounds of non-metals have low melting points and boiling points, so that's a characteristic of covalent molecular substances, low melting points and low boiling points. From these properties we can make the following deductions about their structure. So we know there's molecules, water, carbon dioxide, Cl2, and collecting or looking at all those, we've discovered that they all have low melting points. Think of water, carbon dioxide, relative to our metals and our ionic substances, quite low melting points and boiling points. A lot of them are gases at room temperature. So what do we know, or what can that tell us about their structure? Because this is what we did in metallic and ionic substances as well. We used their properties to formulate a model that we then use to explain their characteristics. So, being low melting point, boiling point, must tell us that the forces of attraction between the particles is very weak. That contrasts with metallic and ionic, doesn't it? So the forces between particles are very weak. No charged particles are free to move through the substance, so they don't conduct electricity. Now the theory for the structure of covalent molecular substances is, and this is the current theory, and it's a pretty good one, the basic units of covalent molecular substances are groups of atoms called molecules. The last video was about getting you to understand what the term molecules are. So that's our basic unit for covalent molecular substances. All molecules of the substance are identical. One water molecule is the same as another water molecule. Adjacent atoms within a molecule share electrons in order to get a full outer shell. So there's the sharing of electrons, that's our covalent bond. The electrical attraction between the nucleus of adjacent atoms and shared electrons causes the atoms in the molecules to be held together, and this force is the covalent bond. So sort of repeating what I said earlier in the previous video, but just with different words. Overall, the charge of the molecule is zero, and so adjacent molecules are held together by what's called weak intermolecular forces. So the covalent bond is within the molecule, and what holds molecules together, or what holds one molecule next to another molecule, is called a weak intermolecular force. And I'll go through this again shortly because that always confuses students. The intermolecular force that holds one water molecule near to another water molecule is not a covalent bond. The covalent bond is the bond of the shared electrons within the molecule, not outside the molecule. So some examples: chlorine, Cl2. How does it work in covalent molecular substance? Well, there's our two chlorines. It's in the 8th column or group in the periodic table in the old school way. So it's in period 7. Period 7. Oh, geez, I'm getting mixed up here. Group 7 in the periodic table. Now, hopefully you spotted all those mistakes. They were deliberate. So it has 7 electrons in the outer shell. This one over here has 7. Now, they're not going to have an electron transfer because that wouldn't solve anything. What they're going to do is share, and we'll show you in a sec. Here it comes. So they're going to share, so that this one has donated 1 electron, this one has donated another electron, and that they're being shared. And so you can see the nucleuses have moved together as well to facilitate that sharing, and now they've got full electron shells. And that there is our covalent bond, a pair of shared electrons. Hydrogen, it's a special case because it's only got 1 electron in the outer shell, and it only wants to have 2 electrons in the outer shell. And so what happens is the electrons now move. Instead of whizzing around their nucleus, the electrons move and have a zone zone of probability that's between the two nucleuses. And so this becomes the electrostatic. That positive is attracted to that negative, and that negative, so that's an electrostatic bond, and that's an electrostatic bond, and so that's what's holding the whole hydrogen H2 together. And that's the covalent bond, a pair of shared electrons. Now, I mentioned intermolecular and intramolecular. Intermolecular, where's my ink? I need my ink back. There we go. Let's just draw on this to make sure we're clear. Oh, can I draw? Yes, I can. Here we go. Oh, we want that a bit thicker. There we go. Inter is the bonding within the molecules. And if I click now, the force of attraction between molecules is called, and let's do this. Jeez, it's a bit slow, my poor computer. And we've got inter, and this is between. Okay, now let's have a look at this. Enough of this drawing. Let's just have a look at what I'm saying. The bonding within molecules. So if I have a oxygen and a hydrogen and hydrogen, there's a single bond there and a single bond there. This is the intramolecular bond. Now if I have another hydrogen there, and they've got the covalent bonds there as well, the intramolecular, there's a force of attraction. Let's just get a different color here, and let's change the size. Is it doing it? So this molecule is actually attracted to this molecule, and we have forces of attraction. Hopefully we can see that. I better press a bit harder. And these are the intermolecular bonds between the molecules. And I'm going to show you a sec how that expresses itself. Let's get rid of all this rubbish drawing. For some reason my laptop's being really slow. Here's a better drawing. There's our water molecules drawn a bit more realistically. So these here are our intra, and these are our inter. And I think I've got some arrows coming. Here's two oxygens with the double bonds between them. This representation, one line represents a pair of shared electrons, so there's two covalent bonds there. And there we go. So the intermolecular, the covalent bonds are there, and the intermolecular are there and there. Always confuses students. They can never remember inter, intra. It's just a matter of getting your head around it and finding a way to remember it. And where's the expression of that? Well, here we have an expression of the intermolecular forces between water molecules. Water droplets. If there wasn't a bond between adjacent water molecules, water would just flatten out and be as thick as one molecule, but it doesn't. It forms these lumps and it has surface tension, and that's why you can get water droplets, because of these the forces between the molecules, the intermolecular forces. So next video we're going to look at electron diagrams, which is just a way of drawing and representing and showing the covalent bonds and the distribution of electrons within covalent molecular substances. Alright, see you later.